Okay, let's dive right into this. Welcome to This Explainer, where we are going to unpack one of the absolute most staggering stories ever told. You know, when we look around at our world today, it feels incredibly stable, doesn't it? The ground under our feet feels permanent. But, as we're about to see, our very existence is not the result of some gentle, peaceful, predictable evolution. No, it is actually the spectacular result of highly improbable, unimaginably violent geological disasters. We are literally sitting here today because of a totally random chain of catastrophes and coincidences that, against all odds, fueled incredible creation.
So, that begs the million-dollar question, right? What makes our planet so special? When you look out into the universe, it is vast, it is freezing empty, and as far as we know, completely lifeless, with one glaring, bright blue exception: Earth. Out of all the infinite space out there, why here? Well, to find those answers, we can't just look at the present day. We have to travel way, way back in time and piece together the history of our planet from the ground up. And to do that, we have to go all the way back to 4.54 billion years ago. Now, if you were somehow standing on the newborn Earth, it wouldn't look like a home. Honestly, it would look like an absolute hellscape. The temperature was pushing over 1,200 degrees Celsius. There was zero air to breathe, just this choking mix of carbon dioxide, nitrogen, and water vapor. Actually, scratch that, there wasn't even solid ground to stand on. The entire planet was just an endless, boiling ocean of liquid rock, constantly getting hammered by cosmic debris. And it's exactly in this totally chaotic environment that our very first catastrophic stroke of luck happens. Picture this: a young Mars-sized planet traveling at a blistering 15 kilometers a second, that's unimaginably fast, slams directly into Earth. The blast wave practically liquefied both young planets, blasting trillions of tons of debris straight into space. But gravity worked its magic. All that rubble formed this glowing red-hot ring around the Earth, which eventually coalesced into a 3,500-kilometer-wide ball. Yep, this is exactly how our moon was born. And what's totally wild is that it was originally much closer than it is today. And that massive impact set the Earth spinning so fast that an entire day lasted just 6 hours.
So, over the next few hundred million years, this incredibly violent world slowly began to shift. Starting about 3.9 billion years ago, we enter this intense phase of heavy meteor bombardment. Then, by 3.8 billion years ago, the oceans start forming this sort of chemical soup. And eventually, by 3.5 billion years ago, the first simple bacteria emerge. But I really want to zoom in on that very first stage for a second, the meteor bombardment, because it sets up this totally mind-bending connection to our everyday lives.
See, those meteors crashing into Earth, they weren't just deadly, lifeless rocks. Locked inside them were these little salt-like crystals, and hidden inside those crystals were minute droplets of water. For over 20 million years, these incoming missiles just continuously bombarded the planet, and those tiny droplets slowly, drop by drop, formed our massive oceans. So the absolutely crucial takeaway here is this: every single sip of water you drink today, every single drop in every ocean, is billions of years old. It literally traveled millions of kilometers through freezing dark space inside a violent missile just to get here. Okay, so once we have oceans, life starts taking its first tiny, tentative steps. Deep underwater, single-celled bacteria are just kind of feeding off that chemical soup. But for life to really take off, it needs a giant leap forward. Enter the stromatolites. These were literally mountains of living bacteria colonies growing right out of the shallow seabed. And almost like magic, well, chemistry really, they started using the power of sunlight to transform carbon dioxide and water into glucose. This is photosynthesis. And this transformation released a vital, game-changing byproduct: oxygen. Without these simple, unassuming underwater bacteria pumping out oxygen over billions of years, virtually every living thing on this planet, including us, simply wouldn't exist.
But as oxygen filled up the atmosphere, continents shifted and massive volcanic activity eventually caused carbon dioxide levels to just absolutely plummet. The Earth basically lost its ability to trap the sun's heat. Which leads us to a pretty crazy question: can an apocalyptic deep freeze actually unlock complex life? Because about 650 million years ago, a massive, unstoppable wall of ice completely entombed our planet. The Earth became a giant frozen snowball locked under a 3-kilometer-thick ice sheet. Honestly, it seemed like the end of the line for life.
But our planet is nothing if not restless. As volcanoes eventually punched their way through the ice, they pumped carbon dioxide back into the air, slowly warming the planet back up. Now here's the crazy part. While the Earth was frozen, the sun's UV rays had been reacting with all that ice to create hydrogen peroxide. Yes, the exact same chemical people use to bleach their hair.
As the ice rapidly melted, that hydrogen peroxide broke down and released a massive tidal wave of oxygen. This oxygen boom literally woke the planet up, paving the way for a sudden explosion of advanced, complex, armored creatures, like trilobites and these massive predators swimming right there in the newly warmed oceans.
Let's fast forward a bit to 540 million years ago. The oceans are just bursting with bizarre, incredible life forms. But if we jump to 460 million years ago, the land masses, they are still completely, utterly barren. It takes all the way until 375 million years ago for the very first creatures to finally walk on land. So why the massive gap? With oceans so full of life, why wasn't anything living on solid ground yet?
The answer is deadly solar radiation. The sun was absolutely blasting the Earth's surface, making dry land completely unlivable. But then, in this amazing twist, the sun's lethal radiation inadvertently created its own shield. About 50 kilometers up in the atmosphere, that radiation collided with the massive amounts of oxygen the plants and stromatolites were pumping out. This reaction converted the oxygen into ozone, forming a protective planetary blanket. And once that shield thickened up, boom, life exploded on land. We're talking giant mosses, towering tree-like ferns, and massive, frankly terrifying bugs like eagle-sized dragonflies and wolf-sized scorpions just conquering the surface. And all of that huge, lush vegetation from 300 million years ago, it has a direct, tangible link to us today. As those towering prehistoric plants died off, their decaying matter piled up into dense, soggy layers. Over hundreds of millions of years, the intense heat from the Earth's core and the crushing pressure from overlying rocks transformed that ancient, rotting forest into seams of coal. So every single lump of coal humanity has ever burned to fire up power stations or warm modern homes is literally just made from the giant plants that died 300 million years ago. But as we're learning, life on Earth is never safe for long. Just as massive reptiles were starting to take over this lush green paradise, the ultimate near miss for life occurred. Roughly 250 million years ago, a staggering 95% of all life on the planet was totally wiped out, in an event we now call the Permian extinction. So how did it happen? What was basically a rapid-fire succession of absolute horrors. A massive plume of mantle erupted in what is now Siberia, pouring out molten rock over an area roughly the size of the entire United States. Ash and toxic sulfuric acid rain blanketed the globe, burning and suffocating everything in its path. The oceans literally turned pink as toxic algae took over the oxygen-starved water. And just to make things worse, the intense global heat melted frozen methane trapped under the seabed, bubbling this incredibly potent greenhouse gas straight into the atmosphere. Global temperatures spiked to 40 degrees Celsius. It literally reset the evolutionary clock.
But eventually, the dust settles. Around 200 million years ago, the planet begins to heal, and this massive supercontinent called Pangaea has formed. Over the next 135 million years or so, Pangaea violently tears itself apart, creating brand new oceans. And, of course, an iconic new species steps up to dominate the Earth, the dinosaurs.
Right in the middle of that era, around 190 million years ago, as those continents were tearing apart, new oceans formed. In those super nutrient-rich waters, millions and millions of ancient fish and plankton thrived and died, eventually carpeting the ocean floor. Over 10 million years, thick layers of rock buried them, and extreme geothermal heat literally cooked those dead marine creatures into oil. So think about this for a second. The gas we put in our cars, the plastic in our everyday lives, the paint on our walls, they all originated from a massive graveyard of prehistoric fish in a newly forming ocean.
Meanwhile, back on land, the dinosaurs are having a great time. They thrived for 165 million years. They survived volcanic eruptions, they survived splitting continents. Honestly, they seemed completely invincible. Until an asteroid, 10 kilometers wide, we're talking bigger than Mount Everest, hurtled towards the Gulf of Mexico at 20 times the speed of a rifle bullet. The impact unleashed the energy of millions of nuclear weapons going off at once. It instantly vaporized everything nearby and sent a massive plume of molten rock engulfing the planet. The Earth's surface temperature spiked to an unimaginable 275 degrees Celsius. In a flash, the dinosaurs' reign was violently terminated. But here's the thing about Earth. It's a planet of relentless opportunity. The dinosaurs' fiery demise opened the door wide open for a completely different kind of creature, our early ancestors, the mammals. Because early mammals were basically just prey to the dinosaurs, they had learned to hide out deep underground or high up in trees. By living underground, they managed to avoid the extreme heat and the raging surface fires of the asteroid strike.
And because they were these scrappy, resilient scavengers who would eat absolutely anything they could find, they managed to thrive in the apocalyptic wasteland, while the much larger, pickier eaters just starved.
Over millions of years, these surviving mammals evolved. By 47 million years ago, we start seeing early primate ancestors. By 20 million years ago, the continents are finally shifting into the familiar positions we know today, with India literally smashing into Asia to push up the mighty Himalayas, creating a massive water tower that serves half the globe. And then, around 4 million years ago, the Great Rift Valley in East Africa opens up.
And this is where it gets really wild. It turns out a completely random geological shift literally dictated our biology. As those tectonic plates shifted to create the Great Rift Valley, a huge wall of mountains grew, completely blocking moisture rolling in from the Indian Ocean. The local climate rapidly got much hotter and much drier. The lush, vibrant rainforest that our ape ancestors lived in just withered away, turning into a flat, arid savanna. With their habitat suddenly destroyed, those apes were forced to travel much further to search for food. They had to stop dragging their knuckles, step out of the vanishing trees, and stand up on 2 feet to see over the tall grass. A random movement of tectonic plates thousands of miles away literally kick-started the crucial human step of walking upright.
From there, the human ascent really kicks into gear. Homo erectus leaves the very first human-like footprints. Then, as the global climate naturally shifted and sea levels fell, a shallow 13-kilometer gap in the Red Sea allowed early Homo sapiens to just walk right out of Africa. As they migrated north, they collided head-on with a massive ice age. But again, even that was an opportunity. Glaciers acting like massive skyscrapers locked up the ocean water, exposing a vital land bridge connecting Siberia to Alaska, which allowed humans to colonize the Americas. And as that ice finally retreated, it literally carved out modern features like the Great Lakes. The very ice that threatened to wipe us out literally paved the paths for us to conquer the globe.
Which brings us right back to right now. Everything you see around you today, the skies above, the water in your glass, the land we build on, the oil, the coal, and human life itself, is the spectacular result of a 4.5 billion year chain of complete catastrophes and total coincidences. We've made it through fire, ice, toxic atmospheres, and massive asteroid strikes. But remember, Earth's story is really only halfway through. It has roughly another 4.5 billion years to go. So I'll leave you with this thought. Knowing exactly how violently and miraculously we got here, what wonders or what terrifying, unimaginable shifts do you think lie ahead for our restless planet?